Hello, pre-calculus student. This video is for chapter 4.6, solve exponential and log equations. So this is the skill that is essential for solving log and exponential work problem. What is an exponential equation? Exponential equation is when you have an equation where the unknown is in the exponent. For example, I have an exponent 3 to the x plus 5 equal to 7, for example. So the unknown is here, right? Or e to the 0.1x is equal to 11. Right? That's called an exponential equation. The unknown x is in the exponent. So I want to before I introduce the method, I want to mention that the old method that you have been using to solve equation, which is minus 5 divided by 3, or let's take root, doesn't work. So if you divide by 3, you cannot cancel the base. The base is not something that you cancel. This means 3 to that many times equal to 7. What is it? Or so if you divide by 3, it doesn't cancel the base. And usually when we do like, x squared equal to 10, I can do root, right? We take this away, so I have an x. But when I do cube root, I don't cancel the base also. So none of the old method that we use would work. So it cannot do that, right? So this is wrong. Dividing is wrong. Rooting is wrong. So none of these would work. So you can like do root or divide by e to change them. But those are the equation that we are dealing with. It helps us to solve work problems. So in 4.7, in the next video or next chapter, we will use this a lot. So you need to master this first. So let's look at this first equation. Method 1 is we write both sides as the same base, then cancel the base. So the basic idea is if I have 3 to the, for example, if 3 to the something equal to 9, I think we did this before when we do log. We would know, I know 3 squared is equal to 9. So I would write 3 as square, then 2 must be 9, right? So kind of like this same idea. So if they are the same base, they should have the same base and then different, the unknown is here, then you would say that they are the same. So the idea is like that. Then technically what happened is you can say I'm going to log base 3 on both sides. The base now can cancel. The only time you can cancel a base is you apply a same log on both sides, and so you would have the x being freed out. But usually people just don't write this step and they just cancel the base. But behind the scenes, the reason why you can cancel the base is you apply a same log. So now let's solve example 1. We have 3 to the 4x equal to 1/9. And I know 1/9 can be rewritten as, rewrite as 3 to the something. 3 to the what? Oh, I know it's 3 square is 9. 1 over means -2. So now I would say 3 to the 4x is actually 3 to the -2. And I apply log base 3 on both sides, so the 3 cancel. 4x is equal to -2 divided by 4. So then x would equal to -1/2 up and simplify. So this is the solution. Okay, the main focus is not by dividing or anything, but compare so that you have the same base. Example 2, 125 to the x equal to 25, 3x minus 2. Can I write 25 as power of 125? Like what? Or can I write 25 equal to 125 something, right? Because this is a 125 base and 25 is not, so it's kind of difficult. You could, but kind of difficult. So what we can do is write them both as the same base. Write 125, I know is 5 cube, right? And I know 25 is 5 square. So I replace both of the base by another base, so they have the same base, 5 square, and then outside do the 3x minus 2 that you have. Now, log AB, log mn equal to log m times n, so it'll be log 3x, 5, 3x equal to 5. 2 times 3x is 6x. 2 times 2 is minus 4. Now they have the same base. I can cancel them. 3x equal to 6x minus 4. I can just solve it as a linear equation. 3x equal to, yeah, so this is just rewriting. This is for rewriting. 6x minus 4. So I am going to do the only number is on this side, so minus 6x. Minus 6x. Minus 6x will be negative 3x equal to negative 4 divided by negative 3. Just a regular linear equation. So x is equal to 4 over 3, and we're done. Okay. The second method is, of course, happen when you cannot write them as the same base. For example, 9 squared equal to 11. Can I write 11 as 9 to the something? It's not possible, right? So you cannot. So you would do, what you can do is add log or ln on both sides, then use log properties. And then you will say, okay, I'm going to log 9 squared equal to log 11. So this is log base 10. After I put both of them behind a log, you can see that I think it's 2x, not 2. Sorry, it should be 2x. Put it in your notes. I should change it so it will show up x because it's not the same. So then you would say now the 2x is behind a log. Use log property. This whole thing can move as a coefficient. So now 2x log 9 would equal to log 11. So you're using log property. And then log 9 is just a number, so you can divide it by 2 log 9. Divide it because you want to isolate x, right? Divided by 2 log 9. So on the left-hand side, you have x. The right-hand side is log 11 in the top, divided by 2 times log 9. And put in the calculator. I'm going to use the graphing calculator. Do I have it open? No. So this is okay, log, what was it? Log 11 over 2 log 9, right? Okay, so I would do, because it's log log 11 divided by, and there's two things in the denominator, I do parentheses, 2 times log 9. So remember to have parentheses, otherwise it's just going to divide by 2 only, 0.5457. That's it. Okay. So what about solve 4 to the power 2x plus 1 equal to 5? We always check if I can write 5 as a base of something, but no, right? So not possible. So I'm going to do log on both sides. Log 4 to the 2x plus 1 equal to log 5. The 2x plus 1 can move, the whole thing can move out. 2x plus 1, the whole thing, and then log 4 equal to log 5. Now you can distribute, but I think I'm just going to do, yeah, we can distribute. So it'll be log 4 times 2, so 2 log 4x plus log 4 equal to log 5. Don't put in the calculator yet, do it at the end. So this log 4 is just a number, so I'm going to subtract log 4 on both sides. So so be 2 log 4 times x is equal to log 4 minus log 5. We can group them as 4 over 5, but I can just keep on doing this. And then I'm going to divide this whole thing by 2 log 4 divided by 2 log 4. Of course, I'm dividing the whole thing. Great. So the answer would be x equal log 4 minus, log 5. This is log 5. Copy error. Log 5 over log 5 over log 4 divided by 2 log 4. Put in the calculator. Okay, so you can see it nicer. Okay, so we would say open parenthesis log 5 minus log 4, close parenthesis, and then divide, open parenthesis, 2 times log 4. Enter 0.0x05. Okay, so this is the how you solve it. Example 5 is you have the exponent and the base is 6.2. So you can have any base, and then add 1, 3.1, all these things. So we have to do cleanup first. Our goal is to have base, exponent, and a number. So I need to clean up the 1 first. X minus 1 equal to 2.1. So still need to clean up the 0.11 divided by 0.11. Okay, it will be 6.2 to the power x minus 1 is equal to 2.1 over 0.11. Okay, so don't put in the calculator yet because you might do rounding. Now I have one base, one exponent, and a number. I'm ready to do log. So add log only when you are in this position. 6.2 to the power. So this is all inside, so I should not do the ending. 6.2 to the power x minus 1. Well, okay. Go to log 2.1 over 0.11. Okay, so it's just a fraction. Now I can move the x minus 1 outside. X minus 1 times log 6.2 equal to log 2.1 over 0.11. Okay, put it on this side. So I'm going to distribute. So I have x times log 6.2 minus log 6.2 is equal to log 2.1 over 0.11. Right. And then of course I add on that side. So it'll be x log 6.2 equal to log 2.1 over 0.11 at log 6.2. Add this, so it's okay. So 6.2 over here. Now I divide it by log 6.2. So I have x equal. So this would equal to x equal to, is a little big stuff, log of 2.1 over 0.11 plus log 6.2, because earlier we have an add, and then the whole thing divided by log 6.2. That's the answer. So let's put it in the calculator. Let's put it like this so you can see it nicer. So be log, so always do parentheses, okay, log, and then this is 2.1 divided by 0.11, then plus log 6.2, close the parentheses, and close again. Now divided by, just in case, I just do log 6.2, 2.6164. Okay, so that's how you do it. So basically, you just need to make sure that you do cleanup and then move the exponent and then add log. No, clean up and then add log and then move the exponent and then simplify. What happened if my base is e? Then instead of doing log 10, I'm going to do ln because it's a little faster. Ln on both sides. This is one base, one exponent, one number. So I'm ready to do. E is 0.4x is equal to ln 2.4. The goal of adding ln is so that 0.4x can move out. 0.4x ln e is just 1, right? Equal to 1. Equal to ln 2.4. You can see that it's so easy to do. Now you have 0.4x equal to ln 2.4, so you just only need to divide by 0.4. So that's why 2.4 over 0.4, and that's done. ln though, ln 2.4 divided by 0.4. Oh, I have to do ln 2.4, I have to close the parenthesis first. Otherwise, I'm dividing inside, which is not what I want. Okay, so remember ln 2.4 divide, you have to close the parenthesis first, so it's 2.1887. Okay, so another function with e. So this too shows up a lot in work problems. So first we have to clean up the 7.5. You can't do ln right away unless there is a nothing in front of the e power. So be of negative 0.2x is equal to 1.8 over 7.5. Now, unless this is an easy number to divide, you just keep it. Now we're going to add ln. So I would have ln e to the negative 0.2x equal to ln 1.8 over 7.5. Then I'm going to move the exponent out. This would equal to negative 0.2x ln e, which is equal to 1, right? Is equal to ln 1.8 over 7.5. So negative 0.2x is, so I'm going to rewrite it, is 0.2x or negative 0.2x is equal to ln 1.8 over 7.5. And I divide it by negative 0.2 on both sides. Divide by negative 0.2. So move to the other side. My x would equal to ln of a fraction, 1.8 over 7.5. And then divided by negative 0.2. So put in the calculator. Can I do? So move it over a little bit so you can see it. Oh, okay. Yeah. Okay, so my answer should be ln, whole parenthesis. Okay, no need to do parenthesis. 1.8 divided by 7.5. Close it. Okay, now after I close it, I divide it by negative 0.2. 7.1356. Okay, so that's how you do solving of exponential equation. In the next video, we'll talk about how to solve log equation. But out of the two, solving exponential equation is most important.